Electrical applications encompass a broad range of principles and practices. Understanding these fundamentals is crucial for anyone working with or around electrical systems. Even without access to specific online resources, a solid grasp of core concepts will enable safe and effective electrical work. Let's begin with the basics. Voltage, measured in volts, is the electrical potential difference between 2 points in a circuit. It's the driving force that pushes electrons through the circuit. Current, measured in amps, is the rate of flow of electrical charge. Resistance, measured in ohms, opposes the flow of current. These three quantities are related by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. This fundamental law is the cornerstone of electrical circuit analysis. Electrical power, measured in watts, is the rate at which electrical energy is transferred. It is calculated by multiplying voltage and current, or watts equals volts times amps. Understanding power is essential for determining the appropriate size of conductors, circuit breakers, and other electrical components. Wiring is a crucial aspect of electrical applications. Different types of wires are used for different purposes, depending on their ampacity, voltage rating, and environmental conditions. The National Electrical Code, or NEC, provides detailed guidelines for proper wiring practices, including conductor sizing, insulation types, and installation methods. It's important to always consult the NEC and local electrical codes to ensure safe and compliant installations. Circuit breakers and fuses are overcurrent protection devices designed to protect electrical circuits from damage due to excessive current. Circuit breakers are resettable, while fuses are one-time use devices. The proper selection and sizing of overcurrent protection devices are critical for preventing fires and electrical hazards. The ampacity of the overcurrent protection device should not exceed the ampacity of the conductors it protects. Grounding is an essential safety measure in electrical systems. A grounding system provides a low impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and energize the circuit. Grounding helps to prevent electric shock hazards and equipment damage. The NEC specifies detailed requirements for grounding systems, including the size and type of grounding conductors and the methods for connecting to ground. Electrical safety is paramount in all electrical work. Always energize circuits before working on them and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Never work on live circuits unless absolutely necessary, and then only with proper training and precautions. Let's delve into some specific electrical applications. Firstly, residential wiring involves the installation and maintenance of electrical systems in homes. This includes wiring for lighting, outlets, appliances, and other electrical equipment. Common voltages in residential wiring are 120 volts and 240 volts. 120 volts is typically used for lighting and small appliances, while 240 volts is used for larger appliances such as electric stoves, dryers, and water heaters. Secondly, commercial wiring encompasses the electrical systems in commercial buildings such as offices, stores, and restaurants. Commercial wiring often involves higher voltages and larger electrical loads than residential wiring. Three-phase power systems are commonly used in commercial buildings to supply power to motors, HVAC systems, and other heavy equipment. Common voltages in commercial wiring include 208 volts, 277 volts, and 480 volts. Thirdly, industrial wiring involves the electrical systems in industrial facilities such as factories, warehouses, and manufacturing plants. Industrial wiring often involves complex control systems, automated machinery, and hazardous locations. Safety is a major concern in industrial wiring due to the potential for accidents and electrical hazards. Understanding electrical drawings and schematics is essential for electrical work. Electrical drawings provide a visual representation of electrical systems, showing the location of components, wiring connections, and other important details. Schematics are simplified diagrams that show the electrical connections between components without regard to their physical location. Being able to interpret electrical drawings and schematics is crucial for troubleshooting and maintaining electrical systems. Let's talk about some common electrical components. 1. Conductors are the wires that carry electrical current. Conductors are typically made of copper or aluminum and are available in a variety of sizes and insulation types. The size of a conductor is determined by its ampacity, which is the maximum amount of current it can safely carry. 2. Receptacles are the outlets where you plug in electrical devices. Receptacles are available in a variety of configurations, depending on the voltage and current requirements of the devices they are intended to serve. Ground fault circuit interrupters, or GFCIs, are special types of receptacles that are designed to protect against electric shock hazards. GFCIs are required in wet locations such as bathrooms, kitchens, and outdoor areas. 3. Switches are used to control the flow of electrical current to lights and other devices. Switches are available in a variety of types, including single-pole switches, three-way switches, and four-way switches. Single-pole switches control a light or device from a single location, while three-way switches and four-way switches allow you to control a light or device from multiple locations. 4. Lighting fixtures provide illumination. Lighting fixtures are available in a wide range of styles and types, including incandescent, fluorescent, LED, and halogen. LED lighting is becoming increasingly popular due to its energy efficiency and long lifespan. 5. Transformers are used to change voltage levels. Transformers are essential for stepping down high voltages from the utility grid to lower voltages that can be used in homes and businesses. Transformers are also used to step up voltages for long-distance power transmission. 6. Motors convert electrical energy into mechanical energy. Motors are used in a wide variety of applications, including pumps, fans, compressors, and machine tools. Motors are available in a variety of types, including alternating current, or AC, motors and direct current, or DC, motors. 7. Control panels are enclosures that contain electrical control equipment, such as circuit breakers, relays, and timers. Control panels are used to control and protect electrical systems in a variety of applications. Electrical troubleshooting is the process of identifying and repairing electrical problems. Effective troubleshooting requires a systematic approach and a thorough understanding of electrical principles. Common troubleshooting tools include multimeters, clamp-on ammeters, and circuit tracers. Firstly, always start by checking the obvious things, such as tripped circuit breakers or blown fuses. Secondly, use a multimeter to check for voltage at various points in the circuit. Thirdly, if there is no voltage, check the wiring for loose connections or damaged conductors. Fourthly, use a circuit tracer to locate the source of a short circuit or open circuit. Fifthly, always de-energize the circuit before working on it and use appropriate PPE. Electrical codes and standards are essential for ensuring safe and reliable electrical installations. The NEC is the most widely adopted electrical code in the United States. NEC is updated every 3 years to reflect changes in technology and best practices. Local electrical codes may also apply, and it's important to comply with all applicable codes and standards. Continuing education is crucial for staying up to date with the latest electrical technologies and code requirements. Many organizations offer electrical training courses and certifications. Investing in continuing education can enhance your skills and knowledge and improve your career prospects. In summary, understanding electrical applications requires a solid foundation in electrical principles, wiring practices, safety procedures, and code requirements. By continuously learning and staying up to date with the latest technologies, you can ensure safe and effective electrical work. Even without direct access to specific online resources, a strong understanding of these core concepts will serve you well in the field of electrical applications. Remember to always prioritize safety and consult with qualified professionals when needed. Electrical work can be dangerous if not performed correctly, so it's crucial to have the necessary knowledge and skills to do the job safely. Always follow the NEC and local electrical codes, and never work on live circuits unless absolutely necessary and with proper precautions.